Hey, hello everyone. Today we are going to solve this problem of the day from GFG. Delete middle element of a stack. It is easy level question. So we are given a stack and we need to delete the middle element of the stack without making use of any additional data structure. So they are defining this middle element as the size of the stack plus 1 by 2, and they have also written ceil. I don't know why, because there is some uh, inconsistency with this statement and the example shown by them. So what they actually mean is, if there is odd elements, if there are odd elements, then we'll delete the middle one, that is 5 plus 1 by 2, that is 3, the third element. And if there are even, then also we'll just 4 plus 1, that is 5 by 2. So 5 by 2 will give us 2 in integer, so we will delete the second index. Now this looks easy if we had to make use of another vector or a stack to store the elements that we are popping, but since we are not allowed to use any additional data structure, what we can do here is make recursive calls. So recursive calls also can keep on storing the popped elements, and once we return back to them, they can be pushed back into the stack. To explain this better, let me show you the example. So suppose the size of the stack is 4, then when we call the recursive function, so let me make it clear, a recursive function also works in stack memory. So when it is called for the first time, what will happen, the top element would be fourth one. Then what we will do, we'll pop that element and call the function again. So now this size will become 3, and we'll do this process again. So the mid element that we need to delete here is 2. So as soon as we reach the stack size 2, what we will do, we'll just remove this, pop this element and return. So now when we return back, so it will go back to this call here. After first we will have a pop statement, then we will call the next one, next call to the recursive function, and after that we'll have a push statement which pushes back this element. So what will happen, that once we return from the required position, we'll keep on pushing back the popped element, which we will store in some temporary element. So we will push back 3 into the stack, and then we'll go back to 4, and we'll also push back this element. So let me show this in code. So I will make use of this function itself. So as I was saying, whenever we, so first let me write this in this manner, that what we will do, we'll store a temporary variable that would be the top value of the current stack. Then we will pop this out, and we'll make call to this function again with the updated stack. So the stack size now is reduced by 1, and once we return back from this call, we'll just push back the element that we just popped into our stack. So this is it. Now how to remove the middle element? So to remove that, we will write a check case where if the current size of the stack becomes equal to size of stack, that was the original size of the stack that we got as a parameter, plus 1 by 2, then what we will do, we'll just pop this element and we'll start returning to our older function calls, and we'll not call this function anymore, and we also don't not need to store this element since we need to delete it. So we'll just return back to the older function calls. So suppose, as I was telling, here there are 4 elements, so the size would be 4 in the beginning. We'll pop 40 and it will be stored in TMP. Then we'll call the function again with the stack size equal to 3, so it will not get passed here, and 30 will also get popped and stored in TMP of that particular call and stored in the stack memory. And in the next call, the stack that would be passed will be 10 and 20. So this if condition becomes true, because 4 plus 1, 5 by 2 is equal to 2, and that is equal to the stack size. So we will pop 20 and we will return back to our older call, where after this the execution will start after this line, where we are not popping, pushing the temporary variable that was 30. Again once we return from this, because it is a void function, we do not need to return. Once we come to the end of this function, it will go to the original call where the top element stored was 40, and will again execute after this line the function s dot push, and it will push back 40 to our original stack. So let us submit it. It passed the test cases, and the solution also gets accepted. So this was all. Hope you liked. See you tomorrow.